Alright, ladies and gentlemen, welcome back. Today we're going to be talking about multiplying polynomials, and they look a little bit gnarly. They look a little bit intimidating. There's a lot going on with these things. You got variables, you got exponents. It's so scary, but it's not a big deal. It's actually a lot easier than it looks. So what we're going to do is we're going to multiply these things together. And I'm looking for a D word. I'm looking for a D word that helps me send this little term, this little fellow right here that's outside parentheses. I want to send him inside the parentheses. So I'm looking for a D word that helps me send this guy into parentheses. We got any takers? What's that D word called? Distribution. Oh my god, I heard it. It's distribution. That's right. So if I distribute these things or distribute them, right, what I got is these numbers times themselves. It's term times term. But if you want to break it down into a simpler aspect, a smoother dynamic, you have this number times this number, which gives you an even 12. And then you got the variable times the variable. So whenever you have the same variable raised to an exponent and you're multiplying these things, what happens to my exponents? What do I do with them? I gotta add them. So here I'm gonna have an x to the power of 4. Excellent. So this term's done. I distributed this guy into this guy, so that's perfect. Check him off my list. He's done. He's dead to me. Next, 4x squared times 2 simply gives me an 8x squared. All right? So whenever I ask you to multiply polynomials, right, whenever I ask you to find the product, I want you to associate the word product with multiplication. Whenever you see a term or a number outside of parentheses, it's assumed that means multiplication, aka using the distributive property. Alright. Once I'm here, I gotta check step 2. Step 2 simply says combine like terms. If you recall, like terms are the same variable, raised to the same power. Here you got the same variable, but they're raised to a different power. If that's the case, if you run upon that, then just pump the brakes. This is going to be your final answer. I cannot proceed. I cannot continue. That's my guy. We'll star by him. That's your final answer. All right? So moving down the road, we got this example here. This example here also says find the product. And again, the product simply means to multiply, to distribute. In this case, this is just like our last example. Here we have to, I'm looking for a term. It's like an acronym. It starts with an F. It's like 4 letters long. It's like... foil! Yeah! I heard someone say it. All right. Calm down. It's not that exciting. All right, so it's foiling, all right? So what I got to do is I got to send these guys in here. It's the same thing. It's like foiling, but it's on steroids. It's a little bit bigger. It's got one more term. All right, so we do this. Stay with me. I know it's pretty exciting. You guys get stoked about this. Here we have x times y squared simply gives me an xy squared. Here we got x times 2y gives me a 2xy. X times negative 12 gives me a negative 12x. So there, we're done. Here on the bottom, I got this guy, so I can't forget about this 2 and his buddies. I got to finish my foiling, right? So 2 times y squared simply gives me a 2y squared, piece of cake. 2 times 2y gives me a 4y scoop. 2 times negative 12 gives me a negative 24. You guessed it. All right? So step 1 says distribute. Done. Check him off my list. He's dead to me. Step 2 says combine like terms. So in this case, I'm looking for same variable to the same power. Do I have any? Any qualifiers? In this case, I believe I do not. So as ugly as this is, I have to pump the brakes. That, my friends, is my final answer. Ding. All right. So last but not least, you're going to stumble upon one of these in your homework. It's called an expansion problem, and it's going to be, I apologize about the glare. That's actually a 3. So this is 3x minus 1 to the power of 3. 3x minus 1 to the third. Sorry about the glare, but you should have came to class. That's why you shouldn't be absent. So real quick, to give you a related example, in something to the third power, what that's saying is something like this. Where's my special purple pen? So to give you an example, if I say like 2 to the power of 3, all that means is whatever this is times itself 3 times over. Right? So that's simply going to be 2 times 2 times 2 to give me an 8 ball, right? So whatever this is to the power of 3 is itself 3 times over. So to give you one more run, if I say 3 to the third, that's going to be 3 times 3 times 3, aka a 27, all right? So when I say expand 3x minus 1, I'm essentially wanting you to multiply 3x minus 1 times 3x minus 1 times 3x minus 1. Say that 3 times fast if you get bored. And, see what you get. Find the product, expand it, multiply it, see what happens, right? So what I'm going to do is I'm going to break this guy out into chunks. 3x minus 1 to the third is a little overwhelming. It's a tad intimidating. So I'm going to break it down into smaller chunks and beat them up and knock them out. All right, so first things first, I'm going to do 3x minus 1 squared, or just times itself twice. 3x minus 1 squared. When I do that, essentially it's back over here. It's foiling, right? But this is a more manageable foiling process. It's a binomial times a binomial, as opposed to a binomial times a trinomial. So this is even easier. So I set you up for success. Let's see what we got. So if I FOIL this thing out, first, outside, inside, last, 3x times 3x gives me a 9x squared. That's correct. All right, if I do it one more time, what do I got? I got a negative 3x. I got a negative 3x, and I got a positive 1. How do you feel about that? You okay with it? All right, well, let's tidy it up then. Step 2 says combine like terms, so help me out. So I got 9x squared minus 6x plus 1. I believe that looks right. So I broke this guy down into more manageable chunks, right? So I got 3x minus 1. This is squared. I got to bring this third one down, this last 3x minus 1. So if I bring him down, 3x minus 1, I got to keep it going one more time. I think you know where this is going. I got to FOIL it one more time. So if I do that, what do I got? I got to send this guy over, scoopty scoop. How about this little fella? And last, certainly not least, this guy. All right? So help me out. I'm going to need some help with this one. It's going to be some heavy lifting, but we can do it. So let's change colors, get a royal blue. We got 9x squared times 3x gives me 27x to the third. I got a negative 9x squared. How about this guy? What's that? That's a negative 18x squared. Keeping it moving, a negative times a negative is a positive. Yeah, I heard that in the back. All right, so what's that? That's a plus 6x. What else we got? We got this little fella. Had a brain fart there for a second, but yeah, they're still firing. That's a 3x. How about this guy? Negative 1. Yeah. All right, take it easy. Take it easy. All right. So from here, we got to implement step 2. We got to combine our like terms. Combine terms, like terms, if you recall, are simply the same variable raised to the same power. Excellent. I thought you were going to say that. All right. So check me out. Do I have any other x to the third? Does he have any friends? Nah. So bring his no friend having self right on down. 27x to the third. How about any x to the squared? Any other ones of those? Yeah, these guys could be friends right here. Skew. All right. So what's that? That appears to be a negative 27x squared. All right, keep it moving. Any x to the powers of 1? Yeah, we sure do. We got these guys in the boxes, right? So what's that give me? That gives me a 9x. And last but not least, we got this guy with no friends and no variables, just that plain old 1. So here in this case, my guy in green, this happens to be my final answer. I've expanded this thing, I've multiplied it out, I've combined my like terms, and I've come to a halt. This is my final answer. I cannot proceed, I cannot continue any further. I'm done. I'm home free. So, on the homework and the practice, or on your tests and quizzes, if they ask you to multiply polynomials, all they're asking you to do is to multiply these things, to expand them, to find the products, to distribute them into the thing, do your foiling on steroids, put a bow on it, wrap it up. Mwah, muy bueno, muy bueno.